Blotchy bases bring bewilderment, post-move problems plague the print process, and a chilly challenge for Polar Filament printing PHA in that cold powder. And, oh yeah, Prusa listened. All this and more, PrintFix Friday, episode 229. Let's get into it. Why am I getting these white stains? Without any context, my answer is very different from this. But we've got a bottom layer on a 3D print here. Someone is doing what looks to be a maker chip or something like that. And the bottom surface of their parts ends up with these white stains on them. This is material degradation or flexing. Realistically, it is a yielding force of sorts that you're noticing in the polymer slightly changing in color. It's a very easy way to solve this. When in doubt, fire! A little bit of heat from a blowtorch or alphabet soup generic creme brulee torches off of Amazon that take butane, super cheap, super nice to have, should absolutely be in your 3D printing kit. Takes this problem down to a non-issue whatsoever. Put all your parts upside down, wave the torch over them, bada bing, bada boom, your problem is solved. Some materials have a higher chance of doing this than others. Some materials just don't care. Other materials, very, very sensitive to this kind of thing. And even flexing of the build plates can create that sticktivity where the polymer is basically ripping itself off the build plate and in the process getting stressed here. Of course, just be careful because too much heat's a bad thing. Speaking of too much heat, my name is Grant. This is 3D Musketeers at PrintFix Friday, where we help you get your printers back to printing with purpose. And if you are going through any issues with your machines and you want us to take a look at them, reach out to us on all the social medias. Links, of course, are in that description down below. I'd like to know from you all, though, with this particular part, have you noticed that certain brands or certain materials are more susceptible to this? In our experience, ABS is crazy susceptible to this problem, but we've had a couple of PLAs, and it's almost always black PLA that is susceptible to this. But since we're printing a lot more PETG these days, things are a little bit different. Speaking of things being a little bit different, y'all got to see this. You're used to seeing a lot of machines behind me, but it's gone. It's gone, and there's a new machine in the shop. There's a Prusa HT90 that Prusa sent over for a 90-day challenge to see if we can take 90 days with no prior anything to pay off an HT90, to basically bring in enough sales to validate the cost of an HT90. And we're going to be taking you guys along for the ride. The challenge is $12,000, 90 days, and we cannot use existing customers. They must be brand new customers that we either find or they find us. So if anyone needs Peak Pec Ultem or any prints for that matter and want to contribute to the HT90 in 90 days challenge, hit us up, and any parts that we can actually show on camera, we'll give a discount to as well. But moving on to an individual here with a Ender 3 V2. We have got the settings here in the photo. They just moved the printer to another room after 6 months of inactivity, and it's just not working. The machine ends up printing that nozzle test line, you know, that the initial purge, and then nothing prints when it moves over to the model itself. We can see that there is some damage to the plate. They say to just go ahead and ignore that, and we can see what appears to be a thin gray line here, and then where it's trying to print. Traditionally, I would say, let's look at that extruder lever arm because they are notorious for breaking. This person has already solved that problem by replacing it with a all-metal extruder up at the top of the machine, so we don't have to worry about that. If your initial purge line on any machine, Ender 3 or otherwise, is very thin, likely you're way too close to the build plate. It would be good to redo the Z offset and re-level the build plate. When you move Cartesian machines, or any printer for that matter, things tend to move a little bit. And especially on older Enders or Cartesian machines that don't have extra supports for their uprights, you have a tendency to get a little bit of frame shifting. That shifting absolutely makes your bed, your Z offset, completely null and void. you kind of have to start all over again. We have an older video on this. Hilariously, it is with an Ender 3 V2 and a Prusa Mini, but it still checks out. We'll card to it so you guys can take a look. But this one is not too difficult, and I would say the best thing to do in a case like this is to start out like the machine is fresh out of the box. Go through, retighten everything, get that bed nice and level, go ahead and run a first layer calibration. And I understand that you're trying to do a smaller part. Put like a 50mm skirt or brim on it, so that'll give you some time to dial in those wheels by hand. We try to get the bed level on machines like this close enough before the print starts, and then we just manually do it while the print is running. Obviously, be very careful to not put your hand in places where you could have a pinch point or things like that. But let me know in the comments on this one, what else should they be looking at? I would be checking the bolts on the uprights. I'd be checking my V wheels, which we did a video on that as well. At that point, I'd be running this machine as if it was brand new and running all the basic calibrations. When we move machines like this, yeah, we just have to always re-level the bed, redo the Z offset. It's just easier than assuming everything is correct. Moving on to someone who's asking for help, and they're saying, help an idiot out. Well, according to some of our comments, I am also an idiot, so I will do my best here. We got a FlashForge 85M Pro. Overnight prints are frequently failing. They're running a 0.25 nozzle, and the machine still runs, but there's no filament coming out of it in the morning. And that, to me, is kind of our first clue as to what's going on here. One, these parts are really big for a 0.25 nozzle. No wonder they're going to be taking overnight. You've got some potential issues that could be happening here. A 0.25 nozzle is a very tiny orifice, and even bits of dust, dirt, debris, hair from animals can get onto the filament and end up causing a nightmare when it comes to dealing with clogs and things like that. You could be getting heat creep from small areas of retraction where you're just up and down with that filament. It is starting to heat creep, it is starting to work harden, and things just aren't working out all that well. These are problems that you can come into when you're dealing with tiny nozzles. If, for whatever reason, you can go to a 0.4, you can lower your layer height to 50 microns very reliably with a 0.4mm nozzle. I don't think that you really need a 0.25. And, you know, if you want to do some of the smaller pieces in the 0.25 nozzle to retain the detail, fine. But these bigger pieces back here definitely don't need it. We're also looking at gyroid infill, which is absolutely not needed. It is a huge waste of time, in my opinion. Go to something like Crosshatch or Adaptive Cubic, kind of depends on which slicer software that you're using. I don't have a ton of experience with Crosshatch. We normally just default to Adaptive Cubic because it's what we've used for years, but I'm told that Crosshatch is like the new hotness when it comes to infill types, I guess. But we've never personally used it because, hey, if it ain't broke, don't break it.
Tell them to call me ASAP as possible. Thanks.
What do you guys think on this one? I think that the 0.25 nozzle, like, that's the glaring issue for me. 0.25 nozzle, way too small, but to be doing pieces this large, you're hurting yourself by doing that, right? A 0.25 nozzle, you're kind of capping out at like 0.175mm layers. Anything higher than that, you're kind of pushing what the nozzle's capable of doing. It's really made for like 50 microns down to 25 micron layers without any issues whatsoever. Big pieces like this don't have any benefit from that. Yes, okay, the surface finish might be a little bit smoother, but filler primer solves the exact same problem, and you're still gonna need to do a little bit of sanding anyways, especially with those supports. Mitch from Polar Filament has had what many would call a bit of a week. We've got one of their extrusion lines here that is, that's not filament, kids. That's pellets. It looks like a hailstone as far as I'm concerned, but that's not supposed to do that. We move on a little bit farther, and he's got some filament here, with the joke being 2mm tolerance, anybody? Not 0.02, which is normally what they run on their line. And then, well, to add insult to injury, it's leaking. We learned some things from Mitch about all of this. So the blotchy filament that doesn't actually look like filament is likely a heating issue, where it's not getting molten enough before it gets to that end extrusion die, I guess is what you would call it, but the nozzle, right, to push the filament out. And that can happen. This, though, is a really stupid thing. And filament line manufacturers, guys, you got to do better than this. This can be caused by the slightest little piece of dirt, dust, debris, whatever, where the actual extrusion die screws into the rest of the machine. And if it is not a perfect seal, things start to leak like this and wreak havoc. It's a really pretty color, by the way. Polar's been messing around with some really neat colors. So if you do want to follow some of the progress they've been doing over Polar Filament, we'll link to their Discord in the description. I hang out there relatively often. Got a great crew of people, and especially if you're in the Detroit, Michigan area, you could just go pick up Filament, and they have a lot of it. And they're always messing around with interesting colors. And from time to time, there are some discounts that are Discord only. Mitch wasn't gonna stop there. Mitch said, well, it's chilly. And you know what we like to do when it's chilly? Let's go print PHA in the snow. PHA, which is a actual biodegradable polymer that is developed by Ecogenesis Biopolymers and extruded onto filament by Polar Filament, generally hates heat. You don't run a heated bed. You often don't even use PEI because it doesn't like PEI. Blue tape, because it's old school like that. But when it's colder outside, you can generally have some fun and print easier with PHA. The bed was actually reading 0 degrees Celsius, hot in at 170, and he was trying to print.
It looks like the little hydraulic thing might have frozen.
Oh,
so we're gonna see what happens here.
When your cutter mechanism, the wiper, is frozen. That's fun. Also, the little happy face wheel, it's kind of cute. I like it. Well, I mean, that kind of worked.
That works.
Task failed successfully.
Oh, it did not like that.
We can see that he's printing on some tape here. Or...
yeah, I think we're digging into the bed.
I guess we should say it's attempting to print here.
I don't think bed leveling works this cold.
That's something to point out, that bed leveling wouldn't work in the snow. Not that I would know, although this weekend is supposed to be one of the coldest weekends on record. I had to ask people in our Discord how to winterize pipes. There is a non-zero chance that Florida man might be getting snow. I'm about 30 minutes north of Tampa, and there is a non-zero chance that there might be some flurries. And if there are, you can bet I will be outside in that snow getting, I don't know, some sort of video for you all, because why not? That would be fun. And of course, throughout this back and forth in the Discord, I was enjoying the fact that it's like 60 to 80 degrees Fahrenheit here in Florida.
Okay, I brought it back inside, and it doesn't seem to care about printing, so I didn't mess up the nozzle.
Back inside works.
Looks like it's doing all right. So I don't know why it doesn't like outside.
I can tell you, because it's freaking cold. Ha. Firmware update. Oh, that looks really cold.
Look at that. It thinks it's -1C.
It can read negative temperature on the bed. That's kind of interesting. I'm actually surprised the machine is even heating up. A lot of printers, when they get below a certain temperature, simply won't heat. I figured you all would enjoy a little bit of insight into the fun of the Polar Filament Discord and the shenanigans that occur over at Polar Filament when they've got a bunch of snow, because why not? And for a material that prefers the cold, let's see how cold that you can actually get. I don't know much about load cells, and those of you out there that have load cell experience, if you don't mind commenting, we're actually trying to get a hold of a few different load cells and be able to read them. We're looking for some smaller ones, like a couple 100 kilos, but I want to get one that's like 10,000 or 20,000 kilo rated for no particular reason. But if you have experience with that kind of stuff, put in the comments. Does the cold impact this as much? Like, a load cell is just, it's a thing that measures flexing. I wouldn't think that this would be an issue, but I don't know. Maybe there's a shrink rate that we have to deal with. I mean, hey, when things get cold, they get smaller. But to the final story of this week, something that's kind of been on my mind lately. Prusa listened, and they listened really fast. Within, less than 3 weeks of us bringing the problem to Prusa, basically being told, nope, can't fix it by support, making a video all about that this is not reasonable. that the Core One L should not have issues being on a UPS. They already have a solution. So we can see right here, changes in 6.5.2, improved AC bed sensitivity to voltage fluctuations. Now, stupidly, I didn't test this before we did the update, but I happen to have a 4 amp variac laying around. We tested the new firmware with a variac, which lets me go lower on voltage and higher on voltage, so we can overdrive the variac, but traditionally it operates like a very, very, very simple dimmer switch. We found that under 95 volts, the Core One L now just shuts off, and above 135 volts, it just shuts off as well. Now, that's here in the States. Other countries, you'll have to try it on your side and see kind of where that lands. I should have checked it on the old firmware, but it didn't. I was more excited to get this machine running. We have been keeping our Core One L running pretty much nonstop, maybe an hour or two in between prints at most, since this firmware came out on the 19th, and I was tagged by at least 2 people from Prusa, a couple of people on Twitter and Instagram tagged us like, hey, they released something to fix your problem. This is what we like to see from companies. Like, people all the time will say, oh, you're a Prusa shill. They don't pay me. They did send me an HT90. I did have to finish negotiating that in Prague, so, you know, fine. But they're not paying us. But I want to be clear, this is the reason that I like Prusa.
The next day.
I spoke too soon. Thought this problem was solved, but it is not. There goes almost 2 days down the drain. They actually freaking listen. How many months were we hounding Bamboo about the NTC thermistor issue in the A1 and the P1S? This list is well over 100 people now, by the way. They are silently fixing the problem rather than, you know, putting out a real fix for anybody to do and allowing people to do it before their machines actually have non-cascading failures, which I think is the more appropriate way than saying it caught fire. It did catch fire, but I'm tired of arguing with people in the chat that don't understand what fire is. This is why we prefer companies like Prusa, because you go through the regular routes. They basically tell you it's no big deal. You disagree. You make a video about it. The company realizes, you know, he's right. And then they solve the problem. Yes, in this case, it's a firmware fix. But this isn't the first time that we've called out Prusa. And certainly it won't be the last. I'm looking at the profiles for the HT90. But this won't be the last time we call out Prusa. But the reason that I keep going back is that they actually listen. This is proof they listen. Now, again, thankfully, it's a software fix. It's not a hardware fix. Hardware fix, obviously a lot more problematic. But since the 19th, we're filming this almost 10 days after this firmware came out. No issues with the AC board problems at all. And we've had a couple of times where the UPS has triggered. When you basically say, look, you all want to sell critical infrastructure editions of machines, but your machines can't operate in critical infrastructure environments, aka generators, battery backups, those kind of things. That's a problem. The company's like, oh yeah, you know, you're probably right. And then they fix it. That's a big deal. So kudos, Prusa. Thank you for actually listening to your customers before it became a systemic problem. This immediately shows me that there's a big difference between companies out there. What do you guys think on this, right? We went through the regular channels. We used support, right? We then, well, we got a loud voice, so we used it. I do believe that we could have gotten other content creators to do the same thing, to make videos and things like that. And certainly there's somebody out there that's got a bone to pick with Prusa that could have made a video all about this. But I'm glad that somebody, or at least a few somebodies, I should say, heard our cry and said, hey, I think we can solve this. Let us work on it. I'm hoping that we can see improvements like this on future and even current Prusa machines. Because if we look, most of the machines that Prusa offers, like the XL, Mark 4S, Core One, and Core One Plus, haven't had firmware updates since November. I'm hoping that we can bring some of these really nice features that we have from the Core One L back into the other machines. I'm really excited for the future of 3D printing, especially when companies listen. But a huge thank you goes out to those channel members whose names are listed right next to me at the $5 tier and higher. If you do want to support the efforts that we do here on the channel, you can do so by joining for as little as $1 a month. That gets you access to behind the scenes content and extra stuff that we do around the shop here that doesn't really make it into videos. At the $10 tier and higher, you get to come hang out in our private Discord server where you see a lot more behind the scenes in terms of what we're doing, what we're changing, and things that, again, don't make it on camera, but even further, don't even make it into behind the scenes stuff. So if you want to enjoy that kind of thing, or maybe you just want some one-on-one help with your machines, we're always there to help you out. That's all we have for you all today. Stay safe out there. Don't forget to call your loved ones. And hey, remember, if you're not happy with the way a company is treating you or treating its customers, best way for anything these days that you can vote is with your wallet. And as always, keep making awesome. Have a good one.